Hey there, in this video we're looking at basic compiler messages that you may get in C++ when you have an error. Now, for new programmers, the issue here is that compiler messages may use terminology that hasn't been covered yet in your introductory course or your textbook. So if you never make an error, you won't see these and it won't be an issue, but you are unlikely to be perfect when you start out. So we really want to be able to make sense of these and be able to respond appropriately when we see them. I should mention there are many different compilers. Here we're using GCC, the GNU C compiler that's built into the free Dev C++ IDE. In other compilers, you will see different messages, but hopefully they'll be pretty similar to what we're seeing here. Okay, here's my first piece of advice. You need to focus on fixing the first error that you see. If you have an error on some line near the start of your code, it's quite likely you're going to get a flood of apparent errors on later lines. For example, if you fail to define a variable properly, then every single line later on where you try to use that variable will become an error. So it's really important that you understand and fix the first error before dealing with later ones. Probably fixing that first error is going to clear up a bunch of stuff, and trying to fix those later errors probably won't do you any good until you fix that first one. So for my first couple of examples, I'm going to use the first program out of the Gaddis C++ textbook, program 1.1 here. Very simple program you see on screen. Think about ways that this could have been mistyped to produce errors. So the very first thing is I'll look at line 3 where it says using namespace std, using the standard namespace to make things a little bit easier. And what if we'd mistyped that? What if instead of std, we'd had ste here? Very close. But when I try to compile this, I get a whole bunch of errors. The very first one, right, you look down at the messages here in red, and it's highlighted up here for the very first error, which makes sense. Line 3, it says, you've got an error because ste is not a namespace name. Now, std is a namespace name, but not ste. But the thing that I want to highlight in addition is that this has triggered a whole bunch of errors on lines that come later on. So for example, down on line 9 now, what it says is count was not declared in this scope. Since you don't have the standard library being used, the standard namespace, now count is unrecognized and hasn't been declared, and now that line is an error. The line after it, line 10, sin is now undeclared and unrecognized. Sin was not declared in this scope. So a couple ways you could have fixed this. Basically, every single line of this program is all now an error because none of the sins are known, none of the counts are recognized, end line is unknown, those are all errors. So I could waste time potentially trying to fix those, but obviously the thing I should really do is focus on the first error, because as soon as I properly spell this std for the standard namespace, now I can compile it. There aren't any errors, and what appeared to be a whole bunch of errors, they're all cleared up. So definitely focus on that first error. Next piece of advice is make sure that you initialize the main function properly. As you should know, every C++ program needs statements inside a main function called main, and the body of that function is surrounded by curly braces. Make sure you have that set up properly. In this first program, let's look at the start of the main function. That's on line 5, and think about ways that could have been possibly screwed up. So first of all, if you forget to have the header declaring the main function here, let's just take that out, that will obviously be an error, right? And you get this error here, expected unqualified identifier before the curly brace token. We'll talk about unqualified identifiers, unqualified IDs a little bit later on. In this case, it's specifically the name of the main function. Main is missing here. That doesn't make sense. So we got to put that back. Other thing you could possibly forget is that all the statements in the main function need to be in these curly braces. So if I forget that opening curly brace, try to compile this, right? I'm going to get apparently a whole bunch of errors again. Every single line is now an error. And the very first thing is that it expected some kind of initializer before the double on line 6. Now the error isn't really on line 6. The error is before that, namely the line before should have had the open curly brace. So if I put that here, now I can compile it, and again, no compiler errors, and I actually have an executable program. Next piece of advice, which is hopefully kind of obvious at this point, don't forget the semicolon that goes at the end of each statement in C++. Now, if you do overlook that piece of punctuation, which is kind of common when you're starting out, you may get an error message on the following line complaining about something that's missing before it. So if you see one of those errors that says something's missing before this, maybe look at the prior line and check and see if you don't need to add a semicolon there. So here's our first program, and as we all know, every single statement in the main function needs to end with a semicolon. What happens if we forget to do that at some point? I'll go to line 6, that's the line that's declaring our 3 variables here, and see what happens if you forget to put a semicolon. I'll hit compile. Again, you actually get a number of errors here. The first one that it highlights is actually line 9, and the error that it's giving us is we expected an initializer before the count. So the problem isn't literally on line 9, it's something before the count, and the only thing that comes before the count is actually up on line 6. So we'll look up here, and I go, oh yeah, that line wasn't terminated properly. I need to have a semicolon there. Now I can compile it. All the errors go away, and I have a valid program. Another common problem for beginning programmers is that if you don't properly define a variable to hold some piece of data, then attempts to use it are going to generate errors that say this variable is not declared. Remember, C++ is a strongly typed language. Before you use a particular variable, you do have to declare what type of data it is. So if you entirely forget to declare your variable, this is going to happen. And the other thing that happens a lot is that if you slightly spell the variable differently between where you declare it and where you actually use it, the compiler is going to treat that as 2 totally different identifiers, and the second one will apparently not actually be declared. So if you get this variable not declared, check and see if you didn't misspell it in the place you're actually trying to use it. Now in program 1.1, again, it's line 6 that has the declarations to our various variables here. Let's see what would happen if we just forgot to include that line entirely. I'll take it out, try to compile it. And so without that, basically every place that is trying to access one of those variables, they're all now errors. The first one that it's highlighting for us is that line 9 where you're trying to send into the hours variable, and it specifically says hours was not declared in this scope. Hopefully you know this term scope at this point. That's the part of a program where a particular variable is permitted to be accessed. And it's supposed to go from the place where it's declared down to the closing curly brace of that particular section, that particular block. In this case, there is no declaration. So this entire block from this open curling brace to this closing curly brace, right, that scope, it's not declared, and so the compiler can't make sense of this if it hasn't been defined properly. Same for all the other variables. On line 13, rate was not declared in this scope. Pay on line 16 was not declared in this scope. So all of these things are unknown identifiers and the compiler can't make use of them. So obviously I need to return that line 6 back. But let's think about what would happen if I made a smaller scale mistake there. Like this last variable pay, what if I had typed that as pat instead? Okay, so I get errors, and the first one that this is highlighting is down on line 17, where you're computing and trying to store a number in this variable. And pretty similar, the message says pay was not declared in the scope. Okay, that makes sense, because currently there's no variable declared that's called pay. But here, it's trying to help us out a little bit more. It also says, did you mean pat? Because there is a variable called pat right now that's pretty close, so maybe that was our intention, right? Sometimes that is correct, and sometimes by making this pat, it would actually fix the problem. But actually, the mistake that I made was up on line 6, and I have to realize that this variable was really supposed to be called pay. It's meant to store the amount of pay in someone's check. The clearest, most obvious name or identifier of this, it really should be called pay. That's what I need to fix. And in this case, there's also a second error, is that it's saying, hey, the way this is currently typed, there's an unused variable called pat. And the way that I have my warning levels raised a little bit, the compiler is also going to alert me if I do have a variable that I did declare and didn't use. Because pretty obviously that's some kind of oversight on my part. I've overlooked something if I did declare a variable and didn't do anything with it. Frequently that's a sign of some deeper problem. So you definitely want to fix that and not have unused variables running around. In this case, really the 2 errors are coming from one single problem. I got to remember to look up at the declaration on line 6 and go, oh yeah, that variable was really supposed to be called pay, and fix that. Now I can compile this. This code will compile without errors, and I have a valid program. Now, my next example actually has 3 different errors, one after the other, with some new terminology that we'll deal with here. One is you may see errors that say unqualified identifier expected, or it might abbreviate it to just unqualified ID in a certain location. Hopefully you know what identifier means. That's a programmer-defined name for a variable or a constant or a function. So you, the programmer, are making up variables and constants. Hopefully you're giving them good names, or what we technically call identifiers. The identifiers come in 2 different flavors. The more advanced thing would be a qualified identifier, which is an identifier with a scope resolution prefix at the start. For example, something like std::count, which is indicating this is coming from the standard library and the specific object is for character output, the cout object. You're probably not doing that as a beginning programmer. Probably what you are doing is you're using unqualified identifiers that don't have a prefix like that. So for example, just a simple basic local variable without a prefix, that's an unqualified identifier. So if you get an error that says unqualified ID expected here, that's a location that probably needed a variable or maybe a constant and you forgot to put it there. So look at that carefully and think about what variable did you actually intend. Second thing here, kind of similar, is the phrase primary expression. So a primary expression is a data holding expression like a variable or a constant, or it could be a numeric literal like an actual number that you type in the code like 12, or it could be a string literal with some characters in quotes that you intended to output or something like that. So a basic piece of data that you need to work on in a particular place. If you get an error that says primary expression expected, then you needed one of these data holding expressions there and you forgot to put it. So again, think about really what variable did I mean here, or what number or what string literal should go here. And the third thing, hopefully this is kind of obvious, is that after a cin, after a sin object statement or something like that, you have this double right angle symbol that we refer to as the extractor operator. You're taking data out of the sin object and hopefully you're sending it to a variable on the right to hold that piece of data. So the thing on the right, it's got to be a variable, something you can change to hold the new data that you're getting. It can't be a constant. It can't be a literal. It can't be a string. It can't be a type like int or float. None of those things make sense. You actually have to have a variable that you declared earlier to receive the data. If you forget to do that, or you put one of these other things that can't actually change to receive data, you'll get this error here that says operator extractor needs a variable. So think about what variable did you really intend to use there. So here's my example with these 3 types of problems, one after the other. Every single line in this program is actually an error. I'm going to hit compile and see what the compiler thinks about it. Okay, so those first 3 lines, line 5, 6, 7 are errors, and it's actually apparently triggered like hundreds of errors after that, but really just these 3 lines have triggered the problems. The first thing for line 5, right, the error, it's highlighted line 5, and it says, we expected an unqualified ID, an unqualified identifier before the equals token. So remember, equals is being used for an assignment. You're sending data to hopefully a variable on the left of the equal sign. You've got to have a variable over there. You can't have a constant, you can't have a literal, and you can't have a type like int. Int is a type, it's not a variable. You've got to have a variable to the left of an equal sign to receive the data. So what I could have done here is I could have actually declared a new variable, maybe name an integer called num, right? See, that's actually a variable, and now that's a legitimate thing to receive the 6 in the assignment statement. So I can compile this, or try to compile this, and at least line 5 is okay. Now, the next thing here on line 6, the error says, we expected a primary expression before the int. So remember, count, you're sending data by the left arrow symbol, the insertion operator, and it's got to be some actual data. It could be a variable, it could be a constant, you could write a number there, you could write a string literal there, but you can't write a type there. Again, int is a type, it's not actually holding data like a primary expression would. So you can't have a type there. What I could have there is like a variable. I could print out the starting value of that num variable. Like maybe num would make sense here. Right, now I can compile this, and at least line 6 is okay. Okay. The other thing here, obviously line 7 it's complaining about, you have this sin object, And we do have that extractor operator. And again, to the right of the extractor operator, you've got to have a variable. Can't have a type, can't have a constant, can't have a literal there. Got to be an actual variable. So the error says there's no match for operator extractor, right? And there's a couple options here, versus what you have on the right. It says a constant character size 6. That's string literal, hello, right? 1, 2, 3, 4, 5, 6, including the null terminator, is a constant, can't be changed, and therefore can't receive data coming from the SYN object. So what you could have done here is you needed an actual variable, like I could have used num. Right? That's the thing that's legitimate to have to the right of the extractor operator, those right arrows there. So now I can compile this. That's a legitimate program. You have a variable called num that's being initialized to 6. It's printing it out to the screen so the user can see what it is, and the user could type in a new value for num there. And that kind of explains those messages that you're seeing around those kinds of issues. And final thing is a little bit more advanced. It's quite likely you won't see this until later in your first course in programming. You may see messages that are talking about variable types that end with an asterisk, like int star or float star or char star or something like that. So the star is what we call pointer syntax, and that's a special type of variable meant to hold the address of where a sequence of data, like an array, starts in your computer's memory system. Now, if you don't already know, an array isn't just one variable, it's a whole group of variables, one after the other, that you're trying to use. In the Gaddis textbook, that shows up in chapter 7 is the first place that appears, and what you would probably be typing to indicate an array would be square brackets. It would be int square brackets or float square brackets to indicate a whole bunch of floats. Now, historically, pointers came first, so they're baked into the compiler messages, and when it wants to talk about arrays, it's going to be talking about int stars or float stars, so you need to kind of expect that. And the problem that will arise why you would see these messages is kind of a common mistake, is to accidentally try to copy one integer into a whole set of integers, or try to copy a whole set of integers into just one, which obviously can't work and doesn't make sense. So in those kinds of mistaken situations, you'll see messages that say, cannot convert from int star to int, which is saying we can't take a whole bunch of integers and pretend that it's just one. That won't work. So if you do see those kinds of messages, think about, is this really what I intended to do? You know, one thing to remember, string literals and quotes are arrays of characters. So if you accidentally mishandle a string, you may get an error message like this. Cannot convert char star to just one character is something that might possibly happen. If you want to learn more about pointers, again, that usually comes later in the course. You can turn to the Gaddis textbook, chapter 9, really introduces pointers properly. You could read it on your own, get a really good head start to this really important fundamental issue in programming. So here's an example from a little bit later in the course. This is from chapter 7 in the Gaddis textbook. This is program 717. And you can see here that we're starting to use arrays. Like if you look in the main function, line 10, they're declaring an array. It's called numbers, and it has a whole bunch of integers in it. It's got 5, 10, 15, 20, not just one integer. That's what we call an array of integers, a whole bunch there. The array size is 8, as you can see. So this has a second function called show values down here. And the intent of show values is you can pass in this array, and it's just going to print all of the different elements on the screen. So if you look at the function prototype to show values up on line 5, there's 2 arguments there. The first one is what we normally do. It's using square brackets to indicate that the first thing you pass into this function is going to be an array. And when you call show values in line 12, you can see, yeah, the first thing they're passing in is numbers, which is an array. It's a whole bunch of numbers, right? They're also passing in the array size so the machine knows how many things are in your array. And you've got those square brackets here in the prototype, and you also have it here in the header on line 23. So maybe an accident that a new programmer might possibly make is to forget these square brackets to say that we're dealing with an array. If I remove the square brackets here and here, now you're not talking about array, you're talking about just one single integer. But line 12 is trying to pass a whole array of integers, because number is an array, a whole array into that one single integer. That's not going to make sense. So if I hit compile, let's see what the compiler thinks about that. Yeah, it's complaining about line 12, and it's saying it's an invalid conversion from int star. Remember, that's the pointer to the beginning of the array. What we normally write as int square brackets. You can't convert an integer pointer into just a regular integer, right? You can't convert a whole bunch of stuff into just one single integer. That doesn't make sense, and this won't compile. So that integer star I'm reading right, that's another way of writing integer array. So what I ought to do is go back and write. If I want to pass an array, I have to indicate it here in the prototype, and I also have to indicate it down here in the function header. Right now, I'm passing an array into a function that knows to expect an array, and this will compile, and I have a legitimate program. So that concludes our primer on basic messages that you'll get from the compiler in C++. And as a starting programmer, hopefully that'll help you make sense of those messages as you begin there, be able to take advantage of that information, fix your programs more quickly, even if there's some terminology that wasn't covered in your course, your textbook there, and move on and become a more productive programmer more quickly. So I hope that helps, and I'll see you next time.